Well, this is the second video for Math 95 on the topic of simplifying radicals. I left all the perfect squares up here so that we can still have those to refer to. Let's see. Most of these problems up through problem 9 are very similar to what we talked about in that first video. And so, well, let's see. Let's do number 6 just to get us started here. So in problem 6, we've got the square root of 48. And again, so you might see, and you might not, that 4 divides into 48. 16 also divides into 48. So that's why it can sometimes be helpful to test a couple of these, at least the first couple out, as many as you want to try. So I'll do this problem both ways. First, I'll split this up as 4, and then if you do 48 divided by 4, you should get 12. Square root the 4. But now the 12 we have to split up, okay? Because the 12 is 4 times 3, so we'll have square root 4, square root 3. The 2 stays the way that it is. Square root the 4 makes 2, and then the square root 3 is not a perfect square, so that stays the way that it is. And there's our 4 square root 3. Now, if you recognize right away, or if you test it out and you find out that 48 is 16 times 3, then you could split this up as square root 16 times square root 3, and that'll take you more directly to the answer. Square root of 16 gives you 4. The 3 stays under the square root because it's not a perfect square. We get the same answer either way. This one is more direct, but it requires you to split this up as 16 times 3 to begin with. This one's a little bit easier to work with because we're using the smaller numbers. They're both correct. There's nothing wrong with either one. Okay, so that's a little bit of review from what we talked about in the first video on this subject. So let's look at the problems on the bottom of the page that involve variables. So let's see here. Well, let's do number 14. Here we've got square root 169, s to the 5th, t to the 10th. Okay, so just like I did in the other problems, I'm going to split this up. We're going to have square root 169, square root s to the 5th power, and square root t to the 10th. Okay, now that 169, you notice I stopped at 144. So something that can be helpful for you, try it. See if it's a perfect square. Square root the number. See if you get a whole number. And if you don't, then you can look for a factor of one of these things in it. But as it turns out, square root 169 is just plain old 13. Square root t to the 10th is t to the 5th. So now we've got this s to the 5th power under the square root. Okay? And so the process for this is to break off an even power of this variable. All right? The highest even power we can would be s to the 4th. That would leave us, with s to the 1st. Right? S to the 4th times s to the 1st makes s to the 5th. And now this thing can get square rooted. Square root of s to the 4th is s squared. We've still got that t to the 5th. And then we're left with a square root s underneath the radical. Okay? So that's the next step in this process. It's a little bit tricky, so let's look at a few more examples here. Problem 16. Let's see what we've got here. Square root 27 t to the 15th power. So again, I'll start by splitting it up. I'll have the coefficient separate from the variable. And you don't necessarily have to do it that way. The idea is that you want to pick out the perfect squares. And this just, I think, it's helpful to think about them separately. So the 27, right, you should hopefully recognize that 27 is going to be 9 times 3, right? So we'll have square root 9, square root 3. And with this t to the 15th power, we just want to break off an even power so we can square root it, and that'll leave a t to the first power under the square root. So this one and this one are our perfect squares, right? So these two are going to get square rooted, and that'll give us 3 t to the 7th power. And then this one and this one stay underneath the square root because they're not perfect squares. So we come out of this with 3 t to the 7th times the square root of 3t. All right, let's look at a couple more. That was 16. So, problem 18. We get 23, k to the 9th, p to the 14th. All right, well, let's split them up into 3 pieces. Here we'll have the square root 23, square root k to the 9th, and square root p to the 14th. Now, 23 is not divisible by any of these numbers, right? I mean, you're not going to go past the 16, really, and it's not divisible by 4, 9, or 16, so it's just going to stay the way that it is, okay? In fact, 23 is a prime number, so it's going to stay underneath the square root. This p to the 14th, square root of p to the 14th is going to be p to the 7th power. Here, with the k to the 9th, right, we want to split this up into k to the 8th times k to the 1st. Because this k to the 8th power is a perfect square, and we can square root it as k to the 4th. Okay? And notice how when I apply the square root, then we don't use that symbol anymore. If I haven't square rooted something, it stays under the root. So what's outside the square root? We've got k to the 4th and p to the 7th. What's still inside? 23k. And there's our answer right there. Okay. So these last two problems are a little bit tricky. Now they start out with something outside of the square root, and that's fine. Okay, we're just going to leave those alone and worry about them after we simplify what's inside here. 50, a to the 11th, b to the 3rd. So there's kind of a lot going on in this problem. This a squared b to the 5th, we're just going to leave that alone for right now. Work on what's going on here. So we'll have a square root 50, a square root a to the 11th, and a square root b to the 3rd. Okay? And we don't need to have brackets there. I'm just trying to indicate how we're just setting this aside for the moment. We'll come back to it after we're done with this section. So each one of these is going to get split up. Right? This 50 is square root 25 times square root 2. The a to the 11th is going to be a to the 10th times a to the 1st. And that b to the 3rd is going to be b squared times b. So, again, here's the perfect squares. That's why we wanted to split these up. And so now we can square root these things. So there's that a squared b to the 5th. This will be 5. We'll keep that square root 2. Square root a to the 10th is going to be a to the 5th. And then we'll have that square root a. And square root of b squared is just plain old b. And then we've still got that b underneath the square root. Excuse me. Let's see. All right, so we're getting kind of complicated here. So let's try to clean it up so that we can get an answer out of this. So let's take all the pieces that are outside of the square root. So we've got a squared b to the 5th, and then 5, a to the 5th, b. And then inside the square root we'll have 2ab. And then the last thing we want to do is clean up what's out here, right? That's what I was saying at the very beginning. We're just going to forget about this until we get to the very end, and then we do a squared times a to the fifth is a to the seventh. B to the fifth times b to the first is b to the sixth. Got the square root 2ab and the 5 outside, and there it is. So, yeah, that is kind of complicated, but notice that this is one of the last problems, so this is about as complicated as we're going to get on these problems. So let's look at one more of these before we finish up. Okay. So, problem 22, again, let's see, I think I'll write it over here. We start out with x to the 7th, y to the 3rd outside of the square root, and then inside 72 x to the 9th, y to the 5th. Now, if you notice, problem 4 was the square root of 72. So if you've already done that problem, then you should have a head start on how that 72 is going to get split up. Okay? Let's see. So again, let's just set these x to the 7th, y to the 3rd aside for a minute, and then we'll have square root 72, square root x to the 9th, square root y to the 5th. Okay, so the 72, there's a variety of ways that we can split this up. It's divisible by 9, right? It's also divisible by 36. It happens to be 36 times 2. So that's how I'm going to split this up. We'll leave this alone for a minute, and then we'll have square root 36 square root 2, right? With the x to the 9th, we want to split that up as x to the 8th times x to the 1st, and the y to the 5th is y to the 4th times y to the 1st. So, just like we did in those other problems, there's a perfect square, there's a perfect square, there's a perfect square. So, we'll come out of this with x to the 7th, y to the 3rd, and then 6 square root 2, right? That's the square root of 36. And then we'll have the x to the 4th, and the square root x, and then y squared, and square root y. So let's pick out all the things that are outside the square root. And then 2xy will stay inside there. So out here we'll have x to the 11th power. We'll have 6, x to the 11th, y to the 5th. And then we'll have that square root 2xy. Okay, so like I said, I understand these last two problems are kind of tricky, but I encourage you to work through them and try to understand how this is all working. And as always, if you have any questions, I encourage you to contact me so that I can try to help you. Thanks a lot.